Did you know Mrs. Burns has 53 first cousins? Well, good news! You don't have to know that many standards to pass the next math test. Now for this test, we only have to master one standard and one standard only. I can use the greatest common factor to rewrite an equivalent addition or subtraction expression, otherwise known as the distributive property.
That's a lot, so let's break it down. What is the greatest common factor?
I know who doesn't have the greatest amount of hair.
The greatest common factor is the largest factor that evenly divides out of the chosen numbers. A great strategy to use to find GCF is Euclid's ladder.
Well, I found the ladder, but where's Euclid?
So let's find GCF with our chosen numbers of 18 and 24. To use Euclid's ladder, we're going to start by building a step to our ladder underneath our chosen numbers. Both of these numbers are divisible by 2, so we're going to write our 2 on the outside of the ladder. 18 divided by 2 is 9, and 24 divided by 2 is 12. Okay, so 9 and 12 are also both divisible by a same number, and that is 3. We are going to extend a step of our ladder underneath the 9 and 12. And then, since they can both divide by 3, we're going to write the 3 on the outside of the ladder. And then just divide. 9 divided by 3 is 3. And 12 divided by 3 is 4. And so now we're done with the ladder part. We don't need any more. Because 3 and 4 are no longer divisible by a common number. All right, the whole point of this was to find greatest common factor. So how do we do that? We look at the left side of our ladder and we circle whatever numbers are over there. Now our answer is not 23, but we want to multiply whatever numbers are out here. And 2 times 3 is 6. So the GCF of 18 and 24 is 6. So we can use our Euclid's ladder to help us rewrite an equivalent addition expression. So we take our GCF, which was 6, and that goes on the outside of parentheses. What goes inside the parentheses are actually your 2 numbers at the bottom of your ladder. You will just place an addition sign in between them. So in my parentheses, I'll write 3 plus 4. And that right there is how we get to the distributive property.
Let's look at a real-world example about vegetables.
Ew, nobody likes to talk about vegetables.
So let's say you're at a farmer's market and a farmer is selling peas and carrots. He has 16, wait, you're not a pea, you're a green bean. He has 16 green beans and 12 carrots. Now let's say this farmer wants to sell these bags so there's an equal amount of peas in each bag and the same amount of carrots in each bag. Now, how would this farmer divide these veggies so that there are 0 left over? Now, this is how he would do it. We use Euclid's ladder to make that first step. Now, both these numbers, 16 and 12, are even numbers. Now, we know that when both numbers are even, you can always divide both by 2. Now, 16 divided by 2 is 8. 12 divided by 2 is 6. Does that check out, green bean?
That checks out.
Perfect. 8 and 6, both even. What can we divide by?
2.
2. 8 divided by 2 is 4. 6 divided by 2 is 3. Now, 4 and 3 don't have a common factor we can divide by. So, we are very close to finding our greatest common factor to divide our peas from our carrots. What we do, take this left side of our ladder. What do we put in between them? Multiplication. 2 times 2 is 4. Our greatest common factor is 4.
Hercules.
Now, we would find we have 4 bags of veggies filled with peas and carrots. Now we could turn Euclid's ladder into an expression. We would do this by taking the 4 bags of veggies we have. Now in those bags, in our parentheses, we have 4 peas and we have 3 carrots. We can solve this expression using the distributive property. We take those 4 bags and we have to multiply it to every term in those parentheses. 4 times 4 is 16. 4 times 3 is 12. We put the addition sign back in. So we have 16 peas and 12 carrots.
So now that you know how to solve distributive property, finding the greatest common factor using Euclid's ladder, you won't be losing all of your hair.